In this lesson, we're going to look at writing exponential functions when we're given tables and graphs. So let's remind you of what an exponential growth function looks like. It's increasing at a very drastic pace. The formula in general is b raised to the x power, where b is your base and it's a value greater than 1. Whereas exponential decay is decreasing very, very rapidly. Same equation, however, your b value is a fraction between 0 and 1. Notice the initial value is 0, 1 in your parent function for both functions. In terms of many application questions, we can look at both exponential and growth functions as a times b to the x power. A is known as your initial value, which will be very useful in word problems. And if you think about the base, I'm going to rewrite it in a different form. I'm going to write it as 1 plus r, and we'll look at this with some examples, but 1 plus r can be known as your factor, like your decay factor or your growth factor, and r is just your growth rate or your decay rate. So an example of an exponential growth function would be like f of x is equal to 2 times 4 to the x power. In this scenario, my factor would be 4, and the rate would be 3, or we could even say 300%. Often we use the notation of rather than x, we'll use a t for time because we're looking at how things grow or decay over time. So here's another example, 12 times 1, I'm going to write it like this, 1 plus 0.06 to the t power. So in this scenario, 1.06 would be my factor, my growth factor, and the rate would be 0.06 or 6%. So an example of a decay function would be 3 times, now my base would be smaller than 1, or but greater than 0. Another one using t for time, f of t is equal to 18 times 1 minus 0.03 raised to the t power. So in this scenario, 0.97 would be my factor, and my rate would be negative 0.03 or negative 3%. So let's see if you can determine for these 6 examples, whether they're growth or decay functions, what the factor, the rate, and the initial value would be. So I'm looking at the first. The base is greater than 1, so this is growth. The growth factor is 1.03. The rate is how much more than 1 it is, so it would be 0.03. And my initial value is 100. Letter B is an example of a decay function because the base is less than 1. The decay factor is 3/4. The decay rate would be negative 1/4, and as a decimal that would be negative 0.25, because often when we talk rates, we're often talking percentages. So negative 0.25, and my initial value is 20. For C, this is growth, again because the base is greater than 1. 3 is my factor, and my growth rate would be 2 or even 200% if we're thinking percents. My initial value is 0.1. Try the next 3 on your own. Hit play when you're ready to check your answers. D is a decay function. Base is less than 1. The decay factor is 0.94. The rate at which it's decaying is negative 0.06. And your initial value is 1500. The next one is growth, because the base is greater than 1. Factor is 1.025. The growth rate is 0.025, or 2.5%, and the initial value is 45. Last one is growth. growth factor is 5. The rate at which it's growing would be 4, or even 400%, and the initial value is 2. Now that we've analyzed the different parts of an exponential function, let's see if you can write one from a table. So the first thing I look for is an initial value, like your y-intercept if we're talking Algebra 1 language. So this is 0, 48. That tells me that my a value is 48. So I'm going to plug 48 in for my a, my initial value, and I need to determine my base. So what I'm going to do is I'm going to pick one other ordered pair, and I'm going to choose 112, where of course this is my x and this is my y, and I'm going to substitute this in to my function. So f of x is the same as y, so I have 12 equals 48 times b to the first power. And now I'm going to get b all by itself, so I'm going to divide both sides by 48, so b to the first, which is just b, is equal to 12 over 48, or 1/4. So my function is going to be f of x equals 48 times b, times 1/4 raised to the x power. This would be an example of exponential decay, and if you look at my y values, they're definitely decreasing rapidly. You could, of course, graph this and check your points to make sure that they satisfy our function. Let's try another. So again, I begin by looking for my initial value. I see that it's 15. So I begin by substituting 15 in for a. I don't know b, and I'm going to choose an ordered pair. Now, I would always advise you to choose smaller ordered pairs to make your life easier to solve it algebraically. So I'm going to plug 540 in for y and 2 in for x. So next I'm going to divide both sides by 15, which gives me b squared equals 36. And now how do I unsquare something? Well, that would be the square root. And where technically there are two answers, I know my base is not negative in an exponential function, so I'm going to only worry about my principal root here, which is 6. So my exponential function will be f of x equals 15 times 6 to the x power. This would be an example of exponential growth. The growth factor is 6 and the growth rate would be 5. Next, we're going to write the function from a graph. So the first thing I notice is that I'm given my a value, it's 0.5 or 1/2. And I'm going to need to find another value along here. So it looks like I have a point right here. And that ordered pair would be 1, 2.5, because each little block here would be a quarter. So again, my function, f of x equals a times b to the x power, and I'm going to substitute 1/2 for a. My base I don't know, but I'm going to use 1 for my exponent and 2.5 for the y value. So I'm going to get rid of the 1/2 by multiplying both sides by the reciprocal, which would be 2. So that produces 5 equals b. So my base is 5. Therefore, my function would be f of x equals 1/2 times 5 raised to the x power. Please try this one on your own. Pause the video, hit play when you're ready to check your answer. So I can see that this is exponential decay. And see my initial value is 2. And I'm going to need another point on my graph. So it looks to me like there's one right here at 1, 1. I'm going to use that because that'll make my life a little easier here. I'm going to plug in my values. And I will divide both sides by 2, which produces b equals 1/2. So my function would be f of x equals 2 times 1/2 to the x power.